డియర్ స్టూడెంట్స్, ఆల్ ఆఫ్ యూ గుడ్ ఈవినింగ్. ఈరోజు మనం కైనమాటిక్స్ వీడియో చూద్దాం. కైనమాటిక్స్లో కైన్ అంటే మోషన్, మ్యాటిక్స్ అంటే మ్యాస్. సో స్టడీయింగ్ ద మోషన్ ఆఫ్ ద ఆబ్జెక్ట్స్. సో కైనమాటిక్స్. So kinematics lo first of all we have to see about what is rest. Rest means if any body, consider a block lying on a table at a time 2 seconds passing, the position of the body there only, time 2 seconds, T2 4 seconds, time T3 6 seconds, time T4 8 seconds. But the position of the body does not change. అంటే ఒక ఆబ్జెక్ట్ టైం వైల్ చూస్తుంటే ఇఫ్ యు అబ్జర్వ్ సి బాడీ టైం గడుస్తూ ఉంటుంది కానీ పొజిషన్ ఆఫ్ ద బాడీ అయితే మారదు. అలాంటి సందర్భం ఏమంటారంటే వి కాల్ ఇట్ యాజ్ రెస్ట్. సి రెస్ట్ ఇఫ్ ద పొజిషన్ ఆఫ్ ద బాడీ does not change with respect to time. If the position of the body does not change with respect to time, then the body is said to be at a rest. మిత్రులారా, ఆబ్జెక్ట్ రెస్ట్ లో ఉంది అని మనం ఎప్పుడు చెప్తామంటే జస్ట్ నాట్ ఓన్లీ పొజిషన్ బట్టి కాదు కానీ టైం కూడా. సో టైము మారుతూ ఉంటుంది, పొజిషన్ ఆఫ్ ద బాడీ చేంజ్ కాదు. పార్కింగ్ లో ఉన్నటువంటి ఒక కారు మీరు అబ్జర్వ్ చేయండి. మనం మార్నింగ్ 10 o'clock పార్కింగ్ చేసి వెళ్ళాము, ఆఫీస్కి వెళ్ళిపోయాము. ఈవినింగ్ 6 o'clock వచ్చి మనం కార్ తీసుకున్నాం. ఆ పొజిషన్ ఆఫ్ ద కార్ వేర్ వీ హ్యావ్ కెప్ట్ ఈస్ 10 o'clock నుంచి 6 o'clock వరకు వాట్ హ్యాపెన్స్ అక్కడే ఉంటుంది. అంటే ద పొజిషన్ ఆఫ్ ద కార్ ఇస్ ఎట్ రెస్ట్. ద బస్ విచ్ ఈస్ ఇన్ ద బస్ స్టాండ్ ఫర్ సమ్ టైమ్ ఎట్ రెస్ట్. ఆల్ ఎగ్జాంపుల్ రెస్ట్. టేక్ ఇట్ ఎనీ ఆబ్జెక్ట్ లైక్ పంప్, ద పొజిషన్ ఆఫ్ ద హ్యాండ్ పంప్ ఎట్ రెస్ట్. సో ఆల్ దీస్ ఆర్ కాల్డ్ example for rest. Now let's come to motion. మిత్రులారా, మోషన్ అంటే చూడండి, ఒక పాత్ తీసుకుందాం. ఇక్కడ ఒక కారు ట్రావెల్ అవుతుంది. ఏ అనే పొజిషన్ దగ్గర కారు ఉంది. అప్పుడు టైము 10 o'clock మార్నింగ్ అనేది, మార్నింగ్ 10 o'clock. కారు కొద్దిసేపు వరకు బి అనే పొజిషన్ దగ్గరకు వచ్చింది. అప్పుడు టైం వచ్చేసి 20 minutes అవుతుంది. కారు సి అనే పొజిషన్ దగ్గరకు వచ్చింది. సో కారు సి దగ్గరకు వచ్చింది. ద టైమ్ ఈస్ 10:30. వాట్ హ్యాపెన్స్? టైమ్ T1, టైమ్ T2, టైమ్ T3. పొజిషన్ డిఫరెన్స్ P1, P2, P3. If you observe, position of the car changing with respect to time. See, position is A. After some time, 20 minutes, position at B. Again position after some time at C. So the time changing, position of the body also changing. కాబట్టి పొజిషన్ ఆఫ్ ద బాడీ చేంజ్ అవుతూ ఉంటుంది, టైం కూడా చేంజ్ అవుతుంది. సో ఇప్పుడు మనం ఇఫ్ ద పొజిషన్ ఆఫ్ ద బాడీ if the position of the body changing with respect to time, then the body is said to be at motion, or the body is said to be in motion. Example for motion, example, a car or bus moving on the road. A car or bus moving on the road. See, it is the sun. Around the sun, all the planets are moving. All the planets are moving. Earth also moving. Venus also moving. Jupiter, Mars moving. So the position of the Earth with respect to sun is changing. So the position of the Earth is different for times and different. So there are so many examples for motion. మిత్రులారా, ఇప్పుడు మనం నెక్స్ట్ మనం రెఫరెన్స్ ఫ్రేమ్ చూద్దాం. Reference frame. So what is this reference frame? Reference frame. See, when we are observing some objects, where we are observing. See, for example, when we are observing particular thing from top of the building to bottom of the building. So the things that are nearer to the building are a ground floor. The things that are fourth floor or fifth floor, they are differently appearing. Similarly, reference frame means ante the background of observations. The background of observations. Where we make observations. ఎక్కడి నుంచి అయితే అబ్జర్వేషన్ చేస్తామో అది మనకు రెఫరెన్స్ ఫ్రేమ్ అవుతుంది. చూడండి, ఒక బోర్డు ఎర్త్ మీద ఉంది. సో ఎర్త్ మీద ఉన్న ఆబ్జెక్ట్స్ ఎర్త్ మీద చూస్తే మనకు అవి కదలకుండా కనిపిస్తాయి. When we are observing from moon, see, we are observing from moon, earth, the whole earth is moving, earth is rotating. So moon is the reference frame. There are two types of frames: inertial frame of reference, non-inertial frame of reference. Inertial frame, non-inertial frame, we will see in NLM, Newton's laws of motion. Newton's laws of motion లో మనం రెఫరెన్స్ ఫ్రేమ్స్, ఇనర్షియల్ ఫ్రేమ్, నాన్ ఇనర్షియల్ ఫ్రేమ్ చూద్దాం. ఇక్కడ బ్యాక్గ్రౌండ్ ఆఫ్ అబ్జర్వేషన్స్. ఓకే ఫ్రెండ్స్, మనం నెక్స్ట్ టాపిక్ లోకి వెళ్దాం. నెక్స్ట్ టాపిక్ ఏంటంటే trajectory. So what is the trajectory? Trajectory in the sense the length of the path. The length of the path is trajectory. Consider a body is moved from A to B. It is moved in the direction A to B. It moved 20 meters. So it moved A to B 20 meters. So what is this? A to B, join the lines A, B, point A, point B, join them. It is the trajectory. See, a body started from P and it moved to Q. Join the PQ. You will get the semicircle. This is the trajectory. See, a body in the hills place is moving in this way. See, so many curves in the path. ఒక బాడీ ఏ దగ్గర స్టార్ట్ అవుతుంది, బి దగ్గరికి క్లోజ్ అవుతుంది. సో దిస్ ఈస్ ద ట్రాజెక్టరీ ఆఫ్ ద బాడీ. కన్సిడర్ an aeroplane moving in the sky. ఏరోప్లేన్ లో నుంచి మనం స్టోన్ డ్రాప్ చేసాం. సో ఏరోప్లేన్ ఇటువైపు వెళ్తుంది, స్టోన్ ఇటువైపు వస్తుంది. See trajectory. If you drop a stone from a aeroplane or a helicopter, how it moves, that is the trajectory. So this is the length of the path. Consider a body is moved from A to B, that is 5 meters, B to C, that is 4 meters, C to D, that is 6 meters. See the one trajectory AB, another trajectory BC, another CD. See A to B in this direction, B to C in this direction, C to D in this direction. See A to B, what is the length of the path? Length of the path AB plus BC and CD. The total length of the path, total length of the path gives
మీ వాయిస్
distance. A body moved from A to D. A నుంచి D వరకు బాడీ ట్రావెల్ చేసినప్పుడు ఫస్ట్ A to B కి వస్తుంది, B to C కి వస్తుంది, C to D కి వస్తుంది. So now how can we define distance? Distance is the length of the total path covered by length of the total path covered by object is called distance. SI unit of distance is meter, symbol m. Distance is a scalar quantity. Distance can never be negative. Distance always positive. Before that, what is scalar and vectors? What is a scalar? A scalar is a physical quantity. Which have only magnitude. It having only magnitude, no direction. Such physical quantities are called scalars. So magnitude, for considering an example, speed, time, mass, length, all these are example for scalars. See, scalar mass is equal to 20 kg or half kg. Here 20 or 1/2 is the numerical value. That numerical value is the magnitude. The magnitude is only positive in case of a distance. For magnitude value positive, Now, the friends, we will see important thing. Another thing, uh, displacement. Next topic, displacement. So, what is the displacement? Displacement. See, it is a regular national highway. As the national highway చాలా లాంగ్ గా ఉంటుంది కాబట్టి, సో ఒక పర్సన్ P అనే పాయింట్ దగ్గర ఉన్నాడు, Q అనే పాయింట్ కి రీచ్ అవ్వాలి. సో ద పర్సన్ స్టార్టింగ్ ఫ్రమ్ హియర్, సో ద టోటల్ లెంత్ హియర్ ఈస్ ఒక 6 కిలోమీటర్స్ ఉంది. కానీ ఇలా 6 కిలోమీటర్స్ వెళ్ళి ఇక్కడ ఓపెనింగ్ ఉంటుంది, తిరిగి మళ్ళీ ఇక్కడికి 6 కిలోమీటర్ ఇక్కడికి రావాలి. సో టోటల్ ది పర్సన్ ఇక్కడ నుంచి ఇక్కడికి 6 కిలోమీటర్స్, అండ్ ఇది ఒక 200 మీటర్స్ ఉంటుంది కదా రోడ్డు, మళ్ళీ తిరిగి అక్కడ 6 కిలోమీటర్స్, మొత్తం 12 కిలోమీటర్స్, 200 kilometers. But government initiated flyovers. So the total length of between P and Q will be only 200 kilometers. That is the flyover. So what you observe? Distance between P and Q is here 12, more than 12, but P to Q in another way 200. So second one is called the shortest distance between 2 points is called as displacement. It is called as displacement. See displacement, yes sir, unit of displacement is, this is also meter. It is a vector quantity because displacement has both magnitude, and direction. Both magnitude and direction. Displacement can be positive, negative, zero also. Displacement can be positive, negative, zero also. See, a person started from point A, traveled 10 meters, travel అయ్యాడు, B వరకు చేరుకున్నాడు. తిరిగి అదే పర్సన్ B నుంచి మళ్ళీ A కి వచ్చాడు. అప్పుడు ఏమవుతుంది? ఇక్కడ నుంచి డిస్టెన్స్ S is equal to 10 meters. సో రిటర్న్ రావడానికి S is equal to -10 meters. A to B is equal to A to B మధ్యలో ఉన్న దూరం ఏమవుతుందంటే 10 + 10 డిస్టెన్స్ డిస్ప్లేస్మెంట్ అవుతుంది. దట్ ఈస్ ఈక్వల్ టు 0. So see, a person moving from x-axis, this is a y-axis, this is a y-dash, x-dash. A person moved from A to towards the y direction. See, covers 20 meters from 0 to some A. Again, the person came back 20 meters. Then what is the total distance? Total distance is equal to, so O to A plus A to O, 20 meters plus 20 meters, that is equal to 40 meters. What about displacement? Displacement is 0 to O to A is 20, A to O is a -20, because the direction is opposite to the original direction. Then displacement is equal to 20 minus 20 is equal to 0. Displacement is 0. Let us consider a triangle or rectangle. It is a rectangle. The body is moved from A to B. Again it came to C and D. Finally reached to A. Between A to B is 20 meters. Here 10 meters. Here 20 meters. Again came back 10 meters. In triangle, in a rectangle, opposite sides are equal. So that's why, what is the distance between A to A? ఒక పర్సన్ ఏ నుంచి తిరిగి ఏకి రావడానికి ఎంత డిస్టెన్స్ ట్రావెల్ చేస్తాడు? Distance traveled by that person is equal to distance is equal to AB plus BC plus CD. AB is 20 plus 10 meters plus 20 meters plus 10 meters plus distance will be 20, 30 plus 50 plus 60 meters. This is only magnitude. There is no direction. A to B one direction, B to C another, C to D another direction. Different directions are there. So person A to A, displacement will be displacement here to 20, 30, 50, 60. But observe, person starting from point, again same to point, returning to the same point, then displacement will be 0. Friends, now what is velocity? We will also see speed. Acceleration. Velocity. Displacement by time. Displacement by time is nothing but a velocity. See, speed is distance by time. Distance by time. So here, SI unit of velocity is displacement per meter, time per second, then meter per second. As displacement is a scalar vector quantity, time is a scalar quantity, but the velocity is a vector quantity. It is a vector quantity. The magnitude of velocity is a speed. The magnitude of velocity is speed. Distance SI unit is distance meter, time is second, meter per second. Speed is a scalar quantity. It is a scalar quantity. SI unit is per second. For both velocity and speed, units are same. Now let's come to the acceleration. So what is the acceleration? Acceleration, friends, the rate of change of velocity of a body. Velocity of a body is acceleration. The rate of change of velocity of a body is acceleration. The rate of change of velocity of a body is acceleration. Acceleration is equal to consider a body is moving from A to B. Here time is initial velocity of the body is u, final velocity is v. So initially it has a u, final velocity v. So velocity is changed. So velocity is changed. That means the body is accelerating. So u v minus u by t. SI unit of acceleration is meter per second square. Meter per second square. V minus u by t. This is the formula for acceleration. Acceleration also vector quantity. Acceleration is a vector quantity. Acceleration is a vector quantity. So acceleration has both magnitude and direction. Acceleration can be negative also. Acceleration can be negative. How? Acceleration can be negative. Sometimes if velocity of the body instead of increasing, so it starts decreasing. See, in such cases we call it as retardation. Retardation. Retardation in the sense de-acceleration. De-acceleration or de-acceleration in the sense it is the negative acceleration. The rate of change of decreasing velocity. The rate of change of velocity acceleration. So retardation is a de-acceleration. Here acceleration will be negative. Acceleration value will be minus 10 meter per second, for example, negative n. So if a train is moving on the track, it starts with a certain acceleration. So v is equal to some velocity is some 10 meter per second square. Again it will be some constant velocity, some 30 meter per second. After some time, its velocity again increases to 40 meter per second. Again, its velocity slowly decreases. It comes to 0. In such situations, if a velocity of a body v is equal to the velocity of a body v is equal to velocity of a body is 10 meter per second, and the final is 5 meter per second. Then acceleration is equal to v minus u by t. Say time is equal to 5 seconds. Then v minus u, 10 minus 5 by 5 is equal to 5 by 5, 1 second, 1 meter per second square. That is the positive acceleration. In case of final velocity will be 30 meter per second square, and initial velocity is some 60 meter per second. Time is equal to 2 seconds. Then what happens? Acceleration A is equal to v minus u by t. That is equal to v value 30 minus u value 60. Time is 2 seconds. Then 30 minus 60 minus 30 by 2 minus 15 meter per second square. Minus 15 meter per second square. Here negative. Negative in the sense deaccelerating. The negative is the acceleration is negative. That is retardation. When the brakes applied, suddenly the velocity decreases. If any body throws vertically upward direction with a certain velocity u, for example, say 20 meter per second, so body throws vertically upward, what happens? Due to acceleration due to gravity value, the body moves from ground to certain point A, B, C, and then maximum height D. what happens? Velocity slowly increasing or decreasing? Velocity slowly, it will become 19, 18, and 17. After gradually, say some here 5 meter per second, 20, no, 15, 15, here 10, here 5, here coming to v is equal to 0. In this case, final velocity becomes 0. Acceleration is equal to v minus u by t. V minus u by t. V value 0 minus u value 20. Time taken to move from ground to maximum height, say 5 seconds. Then minus 20 by 5 is equal to minus 4 meter per second square is negative acceleration. In case of any body from a building tower, consider a building tower dropped. A person dropped the stone here. When it is dropping, u is equal to 0. After dropping, the velocity slowly 2 meter per second, 4 meter per second, 6 meter per second, 8 meter per second, 10 meter per second. So after reaching to the ground, final velocity 10 meter per second. So acceleration time taken is say for 2 seconds. V minus u by t is equal to a. Then 10 minus 0 by some 2 seconds. So 5 meter per second square is the acceleration. In this way, acceleration of the body increasing and decreasing. So increasing acceleration is simply we call it as acceleration. Negative acceleration is a retardation. So velocity is a vector quantity. Acceleration also vector quantity. What is a vector quantity? Any physical quantity is having both magnitude and a specific direction. Specific in the direction in the sense north direction or south direction or west direction, east direction, any one direction, that is specific direction, or forward, upward, backward, upward, downward, backward, forward, any one direction. Next, we will see, friends, speed, velocity. Already we have discussed, but we will learn some important things. Acceleration, speed having four types. One is uniform speed. Uniform speed. The second is non-uniform speed. Non-uniform speed. Third one, average speed. Average speed. Fourth one, instantaneous. Instantaneous speed, friends. So uniform speed, non-uniform speed, average speed, instantaneous speed. Same velocity also, uniform velocity, non-uniform velocity, instantaneous velocity. Next, average velocity. Acceleration also, uniform acceleration, non-uniform acceleration, average acceleration, instantaneous acceleration. These are all different types of velocities and speed and all. Before going to different types, first let us see మొట్టమొదటిగా మనం what is uniform speed చూద్దాం. Uniform speed. Uniform speed.